Question number 6 says that two equal electric currents are flowing through two infinite long wires kept along x and y axis as shown in the figure. The equation of line on which we can expect the resultant magnetic field to be zero is. Now dear students, to solve this question, let us write down the directions of the magnetic field due to each wire in each quadrant. Let us mark this wire as wire A and this wire as wire B. The magnetic field in the first quadrant due to wire A would be inwards, while due to wire B will be outwards. In the second quadrant, the magnetic field due to wire A will be outwards, while due to wire B would be outward as well. In the third quadrant, the magnetic field due to wire A would be outward, and due to wire B it would be inwards. In the part or the quadrant B, the magnetic field due to wire B would be inwards, and due to wire A would be inwards as well. Now dear students, if we see the directions of the magnetic field due to each wire, we can see that they can only cancel out each other in quadrant 1 or 3. So therefore, a line must pass through quadrant 1 and 3 as well. Using this concept, we can easily eliminate two options from this question. That is, option number 2 cannot be our answer, option number 4 cannot be our answer. The possible answers are therefore option number 1 and option number 3. Now dear students, for a magnetic field at any point to be zero, it should be equidistant from both wires A and B. Therefore, the line should be equally inclined with both wires and must be at an angle of 45 degrees from both the wires. The only line that satisfies this condition is the line y is equal to x. And therefore the correct answer for this particular question should be option number 1. Now dear students, let us proceed to the question number 7. Dear students, the question number 7 says that the value of closed integral b dot dl for the closed paths as shown in the figure from largest to smallest is. Now dear students, this question is based on the principle of Ampere's law in magnetic field. According to the Ampere's law, the integral of b dot dl across a closed path is equal to mu naught multiplied by the current that is enclosed by that closed path. Now let us try to find out the value of b dot dl for each path. Let us first consider the path D. The value of b dot dl will be mu naught multiplied by enclosed currents. Now dear students, before proceeding to find out the value of the enclosed current, we must acknowledge the direction of the loop as well. Herein, the direction of path D is given to be anti-clockwise. Now using right hand thumb rule, if we curl our fingers in the direction of anti-clockwise sense, then our thumb will point in outward direction, and therefore outward currents would be taken as positive, whereas inward currents would be taken as negative. Herein, the outward currents are, for example, this current I, this current I, this current I, and similarly all the outward currents are taken positive while inward currents are taken as negative. The outward currents in total are 1, 2, 3, 4, 5 and 6. So 6I are positive currents, whereas inward currents are 1 and 2. So 2 are inward currents which will be taken as negative. So the total current will be equal to mu naught multiplied by 4I. Now dear students, let us try to find out the value of b dot dl for the next path. Let us consider path C. Now again, path C is taken to be in the sense of anti-clockwise, and therefore the outward currents will be taken as positive, whereas the inward currents would be taken as negative. Herein the outward currents are 1 and 2, there are 2 in numbers, and the inward currents are also 2 in numbers. So the value of b dot dl will be equal to 2I minus 2I multiplied by mu naught, that will be equal to 0. Let us consider the next path to be equal to B. and we can see that the sense of B is also anti-clockwise. There are only two currents enclosed by path B, that is this current, and both of these currents are outwards, and because outward currents for anti-clockwise path are to be taken as positive, the value of B dot dl will be equal to mu naught multiplied by 2I. Now let us consider the last path, that is path A. Dear students, path A is also anti-clockwise in sense, and the number of outward currents are 1 and 2. So therefore we can write mu naught multiplied by 2I. Herein an inward current is also present, which is 1 in number, so minus I. That will be equal to mu naught I. So we have calculated the values of B dot dl for each path, and we have to arrange them from largest to smallest. We can see that the largest value is for the loop D, and the next smallest value is for the loop B, and the next smallest value for loop A, and the smallest value, which is 0, is for path C. So the correct order in arrangement from largest to smallest for these paths is D, B, A and C, and hence the correct answer for this particular question should be option number 3. Now dear students, let us proceed to the further question, which is question number 8. The question number 8 says that the ratio of voltage sensitivity to current sensitivity of a galvanometer of resistance R is option number 1 capital R, option number 2 1 by R, option number 3 R square, or option number 4 1 by R square. Now dear students, the current sensitivity that we can represent by SI is equal to the angle moved by the needle of the galvanometer per unit current. It is equal to NBA by a constant, where N is the number of turns in the galvanometer, B is the magnetic field due to the magnets in the galvanometer, A is the area of the loop of the galvanometer, while K is the torsional constant, which is constant for a given galvanometer. The voltage sensitivity, which can be represented by SV, is equal to the angle moved by the needle of the galvanometer per unit voltage. This is equal to NBA by constant, which is the torsional constant, and R. Here R is the resistance. Now dear students, if we divide SV by SI, that is the voltage sensitivity with current sensitivity, we get a value equal to 1 by R. We have to find the ratio of voltage sensitivity to the current sensitivity only, and therefore this should be our answer, and hence the correct answer for this particular question should be option number 2. Now dear students, let us proceed to the next question in our test analysis, that is question number 9. The question number 9 says that the magnetic field at center O due to the given structure is. So a wire structure has been given to us, wherein this part is a circular arc, to be more precise is a quarter circle. Now dear students, we can see that for this particular wire, the point A lies along the wire, that is the angle between the position vector of this point with respect to the wire and the current is equal to 0. Therefore, due to this wire at this point, the magnetic field would be 0. So the only contributing parts of the structure which will contribute to the magnetic field are this part and this wire. This wire acts as a semi-infinite wire for point A, and therefore the magnetic field due to this wire can be written as mu naught I by 4 pi A. The direction of the magnetic field can be calculated using right hand thumb rule. If we place our thumb in the direction of the current, then our fingers would curl in the direction of the magnetic field. Therefore, this magnetic field would be in the direction inwards into the plane. Now, let us try to find out the magnetic field due to the circular arc. Dear students, the magnetic field due to the circular arc can be written as mu naught I by 4 pi a into angle that is subtended by the arc at its center. Here the angle that is subtended by the arc at the center is pi by 2. Therefore, if we substitute the value of theta to be equal to pi by 2, we get a magnetic field of mu naught I divided by 8a. Now dear students, the magnetic field due to this circular arc would be inwards as well. So the net magnetic field would be addition of these two magnetic fields, that is this magnetic field and this magnetic field. So the net magnetic field would be equal to mu naught I by 4 pi a plus mu naught I by 8a. We can take mu naught I by 4 pi a to be common and write 1 plus pi by 2, and the direction would be inwards. Now dear students, if we see the options, the only option matching with our answer is option number 3, and hence the correct answer for this particular question is option number 3. Now dear students, let us proceed to the next question, which is question number 10. The question number 10 says that a conducting wire bent in form of a parabola y square is equal to 4x carries a current I is equal to 1 ampere as shown in the figure. The wire is placed in a uniform magnetic field B equal to minus 2 k cap Tesla. The magnetic force on the wire in Newton will be. Now dear students, in this particular question we have to find the force on this parabolic wire. And to find out force on any wire of arbitrary shape, the formula that is to be used is I L net cross B, where L net is the net displacement between the two ends of the wires, that is from this end to this end. We can see that the net displacement is in this direction. We have to find out therefore the length of this particular part. Now we know that the equation of this parabola is equal to y square is equal to 4x from the question, and the coordinate of this particular point is x is equal to 1. If we substitute the value x is equal to 1 in this particular equation, we get y is equal to 2 and minus 2. Therefore the y coordinate of this point should be minus 2 and of this point should be 2. The length therefore that we have to calculate would be equal to 2 plus 2, that is equal to 4 meters. Therefore the L net for this particular question is equal to minus 4 j cap meters. Now let us substitute the value of L net and B from the calculated values and from the question. F would be equal to, from this particular equation, I has been given to us to be equal to 1 ampere. So 1 multiplied by L net. L net has been calculated to be equal to minus 4 j cap cross B. B has been given to us to be equal to minus 2 k cap Tesla. Now this turns out to be equal to 8 I cap Newton. Therefore dear students, the correct answer for this particular question should be option number 1. Now let us proceed to the next question. The next question is question number 11.